So we'll start with indeterminate forms. So up till now, whatever limits you have learned, whatever the outcome was there was a meaningful limit. Like for example, limit as x tends to a, some function was there of x. You are getting some finite limit L, or you are getting infinity. Either you are getting a finite value or you are getting an infinite value. But there are some also limits which are called as meaningless limits, like limit as x tends to a f of x. On substituting the value for this function, f of x may be a rational function. Okay, always f of x is a rational function. By rational function I mean f of x is equals to h of x by g of x, or h of x to the power g of x, exponential function. So either f of x is a rational function or an exponential function, and when I substitute x is tending to some finite value, I get a non-meaningful limit. That is, either it is infinity by infinity form or 0 by 0 form. Okay, so we have certain types of indeterminate forms, and when we substitute the limiting value, if we get any of these forms, that is infinity by infinity, then 0 by 0, 0 into infinity, infinity into 0, 0 to the power infinity, infinity to the power 0, 1 into 1 to the power infinity. These all are kinds of non-meaningless limits, or also known as indeterminate forms. Now, if you get an indeterminate form while solving the question, so we have a rule to solve it. Anyone knows which rule? Huh?
Sir, can you please repeat?
Repeat
Sir,
what?
hospital.
Sir, the question.
Okay, when we get the indeterminate forms, okay, when we substitute the limit, we have a technique to solve it, or we have a rule to evaluate it. Which rule it is?
The L hospital.
L'Hopital rule. Correct. Now, what is this L'Hopital rule? If on substituting the limit x tends to a f of x by g of x is equals to either 0 by 0 form or infinity by infinity form, then what we do, only a L'Hopital rule is valid for these two indeterminate forms. Okay, 0 by 0 form and infinity by infinity form, and the limit is tending to a finite value a. Then what we do, we differentiate the numerator separately, that is f dash of x, and denominator separately, that is g dash of x. We differentiate them separately and then find its limiting value, that is limit as x tends to a. Again, if we get 0 by 0 form or infinity by infinity form, again successively apply the L'Hopital rule. X tends to a f double dash of x divided by g double dash of x. Correct? Until we get a finite or meaningful limit we continue the process of L'Hopital rule. Clear? What is L'Hopital rule? When we get indeterminate forms, we differentiate the numerator separately and the denominator separately, and then we apply the limiting value. If we get a finite value, we terminate. If we don't get a finite value, we will go on continuing. Now, L'Hopital rule is only applicable for these two forms. Keep this in mind. Not applicable for other forms. Yeah. So after this, now the other forms, how we will convert it to 0 by 0 form. Like I'm telling about this, 0 to the power infinity is there, or infinity to the power 0 is there. Some function is there, f of x to the power g of x, and when we are using this limit as x tends to a Okay, so this function is tending to 0 and this function is tending to infinity. The limits can be applied separately. Now, in such cases, what we will do is we will apply the logarithm on both sides. That is, we assume that this is some equals to some value L, and then we apply log of f of x to the power g of x is equals to log of L. Now, once I applied the log, so by the property of log, that is log a to the power b is equivalent to b log a, correct? So this can be written as g of x into log of f of x, which is equals to log n. So what will be the value here now? Can anyone tell me? On applying the
Sir,
limit.
Sir, then we will get LHS will be 0, sir.
LHS will be 0. How?
So because one term is 0, sir.
One term, see which term was 0, that is inside log, no? And
Oh,
log
okay,
of,
okay.
and the
Okay,
log of
that is
0.
okay, okay. I thought GX is 0. Okay.
Okay. So this will be now in, and 0 into infinity is 0.
No, sir. Sorry, sir. It's indeterminate again.
Okay, it is an indeterminate form. So this will be now either 0 into infinity form, or like the questions will be given like this only, or it will be infinity into 0 form. Now you cannot apply L'Hopital rule for this, but you can write 0 as 1 by infinity. So this can be converted to infinity by infinity form, or infinity can be written as 1 by 0 or 0 by 0 form. And now you can apply the L'Hopital rule over here. So at last, if they give you a function of this type, you apply the log, and then you convert it to infinity by infinity form or 0 by 0 form, and then apply the L'Hopital rule. Clear? And remember,
Yes, sir.
on RHS it will be always log of L. So when so once you have to find L, what you will do, you will take the reciprocal of log, that is e to the power some value is there, that value, that will be your answer, limiting value of this function.
Okay, sir.
Okay, now what does L'Hopital rule tells us? That either you try to evaluate this limit f of x by g of x, or you try to find the limit of this. Both are equal. Why is this? There is some curve here. Okay, suppose this is your curve f of x, and suppose this is your curve g of x. L'Hopital rule tells us that individually their limit exists. Individually, their limit exists finitely or infinitely, but they have a meaningful limit. Now, if they have a meaningful limit, then this means that it has a smooth curve, and a smooth curve is infinitely times differentiable. Okay, smooth curve in the sense mod x. If you go to see the graph for mod x, it is pointed. So here it is point, so it is not called a smooth curve. Smooth curve meaning is actually at a one particular point you are able to draw only one tangent. Okay, at any particular point, if you are able to draw only one and only unique tangent, then that curve is called to be smooth curve. And if a curve is smooth, it is infinitely times differentiable. So whatever indeterminate forms we get, all the functions we get have smooth curve. Okay, none of them has like this type of curves. Okay, non-smooth curve. So in L'Hopital rule, whatever functions we get, that each and every example, if you see f of x and g of x separately, there will be smooth curves. So it's infinitely times differentiable. Understood? L'Hopital rule significance.
Yes, sir.
Okay, so we use that if it is one time differentiable. Since it is a smooth curve, it is infinitely times differentiable only. That is the property L'Hopital used to derive the limit of the function. Now, if L'Hopital rule is clear, so I'll write down the L'Hopital rule, note it down accordingly. If f of x and g of x, please mute yourself. If f of x and g of x be two functions of x such that they are continuous and having a smooth curve. Second point, they are derivable infinite times due to its nature. Third point, limit as x tends to a f of x is equals to 0 equals to limit as x tends to a g of x. Then limit as x tends to a f of x by g of x is equivalent to limit as x tends to a f dash of x divided by g dash of x. So whatever I explained it now, just it is in the form of statement. Clear? Provided this limit exists finitely or infinitely. Okay, so whatever limit we get, it might be finite or infinite, but we don't want indeterminate forms. And until with the indeterminate forms vanishes, we go on differentiating it n times. So try this problem. Understood?
Sir,
Yeah.
sir, can you go a little up, sir? I didn't noting it down, sir.
Okay.
Sir, I have a question.
Yeah, tell me.
Sir, tomorrow you told that if limit exists, then LHL and RHL should be equal to a unique value. But if it's infinity, then how limit exists?
No. Here, whatever I am talking is about meaningful limits. What is your question? Tell me. Yesterday, when I told that limit exists, okay, limit exists finitely only when LHL is equals to RHL, and they also both have finite values. Okay.
Okay, sir.
And after this, you what other doubt you have? Infinity.
Sir, now I got, sir. When you said limit exists finitely, I got.
Okay. So limit exists finitely means LHL equal to RHL and has finite value. And this also implies that function has unique limit. Okay. And if a
Yes.
function has unique limit, this implies that limit exists finitely. Okay, they are if and
Yes.
only if condition. If either of this fails, then we say that unique limit does not exist, because there are some functions. You people don't have function of several variables. Okay, so when you study higher level, so there will be some functions x square plus y square divided by x plus y. Okay, or x plus y divided by x square plus y square. Now, what you do is you generalize this in polar coordinates. That is, x is equals to r cos theta
R constant
and y is
and
equals to
R sin theta.
r sin theta. You try to generalize this in the polar coordinates. So now what will become? Now this limit will be limit as x comma y tends to 0 comma 0. Okay, but once you use the generalization, now this will be limit as x tends to y. Yeah, consider it as like this. It will be is x into y. So this will be r square sine theta cos theta. Since we have used the polar coordinates, now this will become theta tends to 0 will be your new limit. R square sine theta cos theta divided by x square plus y square will be r square. Now r square will get cancelled, and whatever the theta is there, whatever the limiting value is there, will depend on theta. And for different values of theta, we will get different values of limit. So it is not unique in that case. Okay, so directly we conclude from here that the limit does not exist. Understood? Okay, so this is not related to your topic, so don't worry. Done.
Yes, sir.
So try this problem. Limit as examples. Limit as x tends to 0, 1 plus x to the power n minus 1 divided by x.
Sir,
Yeah.
sir, this is equal to n times 1 plus x raised to power n minus 1.
Okay, because once we substitute the limiting value here, it will be what? 0, 1 to the power n minus 1 divided by 0. And we know that 1 to the power n is 1 only. So it will be 1 minus 1 divided by 0. Nothing but 0 by 0 form.
Sir, also, sir, there is like, sir, there was one limit that you gave us. Limit x tends to 0, x n minus a n upon x minus a is equal to. So we can use that also.
N times a to the power n minus 1.
Yes, sir.
Okay, but here minus 1 is not there, no?
So we can add and subtract, sir. And then we will get x minus a only, sir. We can add 1 and subtract 1. So we'll get x with x value term, which is 1 plus x. And we'll get a value term, which is 1.
Where you'll add 1 and subtract
In
1?
the denominator. In the denominator itself.
Then after this, what you'll do?
Then 1 plus
This
x
is
will
1
be
plus
x.
x and this will be a minus 1. Correct.
Yeah, we can do this also.
Yeah. So the answer will be n times a to the power n minus 1. Or using L'Hopital rule, we can differentiate the numerator separately and the denominator separately. That will be n times 1 plus x to the power n minus 1 divided by 1. Differentiation of this is n times 1 plus x to the power n minus 1, and separately is 1. Don't use the quotient rule, okay? So as x tends to 0, this will be 0. 1 to the power anything will be 1 only, and n is your answer. Okay?
Okay, sir.
Now try this. So there are like one question is sure from indeterminate forms in your exam. However, they might ask. Limit as x tends to 0, x to the power x into e to the power x minus log of 1 plus x whole divided by x square. Yeah, tell me its value. If this is equals to alpha and alpha is finite, then alpha is equals to what is the value of alpha? I think you should differentiate this two times, right?
Sir, is it 3/2?
Maybe I have to check. Yeah, 3/2 is the answer. Okay. Got it, Sumedha? Sumedha, got it?
7 minutes, 7 minutes.
Okay. Till then, try this question. See, limit as x tends to 0, x minus tan x divided by x. See, this once you substitute the limiting value 0, this will be 0 minus log of 1 is again 0. 0 minus 0, 0 divided by 0 form. Correct? So what do you do now? It is 0 by 0 form. So you apply the L'Hopital rule, that is differentiate numerator separately and denominator. So it will be x e to the power x plus e to the power x minus 1 by 1 plus x divided by 2 times of x. Now again you substitute the limiting value, x tends to 0, this will be 0, this will be 1. Okay. So this will be 0 plus 1 minus 1 divided by 0, again 0 by 0 form. So again you differentiate this term, that will be x e to the power x plus e to the power x 2 e to the power x minus of minus plus 1 by 1 plus x to the whole square divided by 2. Now as x tends to 0, that is limit as x tends to 0, this will be 0, this will be 2 plus 1 divided by 2. So the answer is 3/2. Finite value. So value of alpha is 3/2. Understood?
Yes,
There
sir.
is the answer of 3 minus 1.
This one,
Yes, sir.
recheck. What if I tell you this question has come in the exam?
Sir, is it 0?
Yes, sir,
No.
it is 0, sir.
Mhm. So see, uh, once I substitute the limiting value 0, this will be 0 tan 0 is 0 divided by 0, 0 by 0 form, correct? So we will use L'Hopital rule. Limit as x tends to 0, differentiation of x is 1, tan x is sec square x divided by divided by 2x. Now, again, once I substitute the limiting value 0, this will be sec 0. Sec 0 is 1, 1 minus 1, that is 0, 0 by 0 form. So, once again, I'll use L'Hopital rule, that is limit as x tends to 0. This will be minus 2 times of sec x, and differentiation of sec x is tan x divided by divided by 2, correct? 2 will get cancelled, and limit as x tends to 0, this will be what? 0, correct?
Yes, so I said this only, sir, right now.
Yes, sir.
Okay. So next question. Okay, if it would be x cube here, then so this would be 3x square, then this would be 6x, correct?
Yes, sir. Sir, we would have to do it one more time.
No, we have to do only one more time. Then this will be 3
Sir, tan x upon x will be 1.
Okay, actually there is a printing mistake in the book, and they have got answer as minus 1 by 3. So it is like this now. Minus 1 by 3 will come out. This will be sec x into tan x by x, correct? And we know that limit as x tends to 0, tan x by x is 1. Agree? Tan x by x is 1, no? Limit as x
Yes,
tends
sir. Yes, sir.
this will be minus 3, and the sec 0 is 1 into 1 into 1. This will be nothing but minus 1 by 3 is the answer. Clear? So just if we change the question a bit, the answer will also change. Now, this question was asked in an exam. Suppose limit as x tends to 1, x to the power x minus x divided by 1 minus x plus log x is equals to minus alpha, then the value of alpha is option A minus 2, B minus 1, C 0, D 2. See, once you substitute the limiting value 1, this will be 1 to the power 1 minus 1 divided by 1 minus 1 plus log
Sir,
of 1. Huh.
sir, we'll do this, sir.
Okay, you'll try to do it.
Yes, sir.
Okay, so I'll tell how it is. It is 0 by 0 form. Understood? No? Try to do it.
Yes, sir. So the answer is -1.
-1.
Yes, sir. Sir, is it -1, sir?
Let even Sumedhan try. Let's see. Recheck your answer once. Thing.
No, sorry, sir. I checked it, sir. It is A, sir. I am -2, so sorry.
Again, recheck your answer. Sumedha got it. X to the power x differentiation is
Sir, x to the power x into 1 plus log x.
okay. So how you'll do? You'll do this. U is equals to x to the power x. Then differentiating both sides with respect to x. Or no, first you apply log on both sides. Log u will be equals to x log x. Now once you differentiate this, it will be 1 by u into du, which will be equals to du by dx. This will be equals to x as it is. Differentiation of log x is 1 by x plus log x as it is. Differentiation of x is 1. X will get cancelled. So your du by dx, that is differentiation of this term with respect to x, will be nothing but u into u is nothing but x to the power x 1 plus log x. Clear? So now here we have to apply the L'Hopital rule, that is limit as x tends to 1, x to the power x 1 plus log x minus 1 whole divided by 1 minus x. 1 is 0 minus 1 plus 1 by x. Now again, as x tends to 1, this is log 1 0 1 to the power 1 minus 1. Again, this is 0 by 0 form.
Yes, sir.
So we apply the L'Hopital rule again. So limit as x tends to 1, x to the power x log x to the power x differentiation is 1 plus log x as it is. X to the power x differentiation is x to the power x 1 plus log x plus x to the power x as it is. Differentiation of 1 plus log x is 1 by x.
1 by
Minus 1 differentiation will be 0 divided by
-1 upon x square.
minus 1 upon x square. Now as limit as x tends to 1, this will be 0. So 1 into 1 plus 0 plus 1, okay, 1 into 1, correct, divided by minus 1. So this will be 2 divided by minus 1, which is nothing but minus 2. This they
Sir, I
have
said
given.
minus. Sir, I said -2 only, sir.
This is given to be equals to minus alpha, no?
Oh, okay, sir. I was only giving the value of alpha. Sorry,
See
I was
here,
only
then
giving the. Sorry, I thought I didn't read the question, sir.
that's what you people make the mistake. So I took up this question. So then the value of alpha is, they don't make hurry, you people get the answer, but Okay, minus minus sign will get cancelled. And the value of alpha is equals to 2. Clear? Understood the question?
Yes, sir.
Okay. So you people have studied hyperbolic functions. Hyperbolic functions you people have studied. Try this question. Limit as Sumedha understood. Sumedha only no name.
Yes, sir.
Sumedha Gupta, correct?
Yes, sir.
Then now limit as x tends to 0 e to the power x minus 2 cos x plus e to the power minus x divided by x sin x. Tell me the value. No mistakes this time, okay? Indeterminate forms will do a plenty of examples. So like each and every, this is one unique kind of example. So mark it. It might come.
Sir, is the answer 4, sir?
2.
4, sir.
4. Let me check. Okay. So mark this because the differentiation of x to the power x, this might come in maxima, minima also sometimes. Answer is what? 4.
Yes, sir.
Jain, why you are making this question? Recheck it. See.
Sir, I checked it, sir.
Chalo. So once we substitute x is equals to 0, this will be e to the power 0, 1. Sumedha, you got it?
Sir, 1 minute, sir.
Okay, try.
No, sir. Sir, I got, sorry, sir, I made a mistake, sir.
Hmm. Sumedha, getting it or finding it difficult?
Sir, 1 minute, sir, 1 minute, sir, 1 minute.
Okay.
Sir, should I like message you answer, sir?
Okay. First,
In the chat only to you.
Sir, -2.
-2 साइन में गड़बड़ी हुई है. Okay, 2 is the answer. So see, once you substitute, it will be 0 by 0 form. So I'll directly use L'Hopital rule. Limit as x tends to 0, e to the power differentiation is e to the power x plus 2 sin x minus e to the power of minus x divided by x cos x plus sin x. Now, as x tends to 0, this will be 1, this will be 0, minus 1. 1 minus 1, 0. Again 0 by 0 form, because here x into is there. So this is 0 by 0 form. So use the L'Hopital rule again. Limit as x tends to 0, e to the power x plus 2 cos x plus e to the power of minus x. So now this will be x minus x sin x plus cos x plus cos x. Correct? So now as x tends to 0, this will be 1 plus 2 plus 1 divided by, first term will be 0. This will be 1 plus 1. 4 divided by 2, answer is 2. Understood?
Yes,
Yeah.
sir.
Now, don't make mistake in this question. This question has came into your exam. I'll just twist a question a little bit so you people pay attention. Suppose limit as x tends to 0, tan x minus x divided by x square into tan x is equals to L, then the value of L is option A, L by root 3. I'll change 1 B3 C 1 by 3 D 1 by root. See what is given, what they have asked. They have asked the value of L. Don't make mistakes, take time. Got the answer? Guys, got the answer?
1 minute.
Finding anywhere difficult, it's taking so much time.
Oh, no, sir, I got it, sir. Just a second, sir. I got it.
Okay.
Sir, so we have to find L, right?
L, the value, then the value of
Sir,
L is
I think L is equal to 1 upon root 3.
1 upon root 3.
Yes, sir.
Correct. Okay.
Sir, it was actually a very long. Actually, first I thought I was doing wrong, but then I thought that this is the only method. So I started again, and then it was very long because I had to differentiate it like three or four times. I think 3 times.
Mm-hmm. So, like in the exam, actually they had asked it like this: equal to L, then the value of L is, then it would be 1 by 3. Correct. So I just divided it by root 3. So we'll do this. Sumita got it.
No, sir.
No problem. So limit as x tends to 0, tan x minus x divided by x square into tan x. Now, see, this tan x is causing me a problem in the denominator. Limit as x tends to 0, this will be 0 by 0 form. Agree? Now, this tan x is causing a problem, but I know that I can eliminate this. By how? By dividing it by x and multiplying it by x cube. That is, multiply and divide this tan x by x into x. Now, as limit as x tends to 0, this value is what? 1. This value is 1, no? Okay. So, limit as x tends to 0, tan x minus x divided by x cube. This one x square and this x. It will become x cube. Now, try to substitute the limit 0 by 0 form, and the tan x is eliminated. So now it will be much more easier to solve. How we will do it? Differentiation of tan x is x square x minus 1 divided by 3x square. Limit as x tends to 0. Now,
Oh, sir, now it is easy, sir, because you can write tan square x and
0 by 0 form. Correct? Now sec square x is nothing but tan square x plus 1 or minus 1. Minus 1, no? Tan square is equals to sec square x plus 1. So instead of that, directly we can like do a one more time differentiable. That will be nothing but limit as x tends to 0, 2 times sec x into tan x divided by 3 to the 6x. Now this tan x by x is 1, 2 1s are 3s are. This is 1, 1 by 3 is the answer.
Yes, sir.
Now they have said this is equals to L by root 3. So what is the value of L? L is equals to 3 divided by root 3 divided by 3. This can be written as root 3 divided by root 3 into root 3. Will get cancelled. Value is 1 by root 3. Answer D. Understood? So what method you people have did? So you'll find certain examples where like see, eliminating tan x from the denominator made it an easier task. If you go and separate to write it also, tan x divided by x square into tan x minus x divided by x square into tan x. Correct? Tan x will get cancelled. 1 by x square minus here xx will get cancelled. So 1 by x tan x. Now after this, what you will do? X tends to 0. This will be 1 by 0. Infinity minus infinity form. But can we apply the L'Hopital rule here? Because it is infinity minus infinity form. No. Starting
No,
only
sir.
I told 0 by 0 form or infinity by infinity form. Only for these two forms, L'Hopital rule is applicable. Again, if you take the LCM, you'll get back to this only.